A deep and disquieting observation in science is the subtle conflict known as the Fermi Paradox. This enigma stems from the clash of two straightforward, potent concepts: the strong likelihood that life is widespread throughout the cosmos, and the absolute resounding silence we encounter when we search for it. This isn't a marginal concept. It's a fundamental query derived from the data we've collected about our universe. To grasp the profundity of this quiet, one must first recognize the immense potential for life's existence. The astronomer Frank Drake made the initial attempt to formalize this in 1961 using a probabilistic framework, which is now called the Drake equation. It deconstructs the overarching question, "Are we alone?" into a sequence of more approachable, albeit still highly uncertain, components. The initial variable in this equation represents the average rate at which stars form in our galaxy. Based on comprehensive observations, we have a relatively solid understanding of this figure, approximating that around 1 to 3 new stars, on average, are created in the Milky Way annually. This establishes a constant and ongoing production of potential new abodes for life. The current belief is that almost every star in the galaxy hosts at least one planet, bringing this fraction to nearly 100%. It appears the universe is remarkably proficient at creating worlds. This introduces the idea of the habitable zone, the specific orbital path around a star where conditions allow for liquid water on a planet's surface. Current projections, informed by the discovery of thousands of exoplanets, indicate that a substantial portion of stars, perhaps 1 in 5, harbor at least one rocky, Earth-sized planet in this region. This single factor suggests the existence of tens of billions of possibly habitable worlds within our Milky Way galaxy. Although we possess only one data point for these variables, our own Earth, the vast number of potential chances implies that even if these percentages are exceedingly low, the resulting count of communicative civilizations ought to be much higher than 1. How long does a species, having achieved our technological level or greater, manage to survive and transmit signals of its existence? This component compels us to face not only astronomical odds, but also sociological and existential questions. A civilization could potentially last for millions of years, or it could self-destruct within a few hundred. The paradox gains further weight when one considers the factors of time and expansion. Our galaxy is more than 13 billion years old, whereas our solar system is a comparative newcomer at roughly 4.5 billion years old. This implies that billions of years have been available for other civilizations to emerge, develop, and spread. A society with the ability to build self-replicating probes, known as von Neumann probes, could dispatch them to neighboring star systems. After arriving, these probes would utilize local resources to build duplicates of themselves, which would then travel to even more star systems. Through this method, a civilization could survey or inhabit the entire Milky Way in only a few million years, a mere blink of an eye in geological terms. The calculations suggest the galaxy should be abundant with life, yet the evidence indicates it is barren. This filter could manifest as any number of improbable events, and its relevance to humanity hinges entirely on whether we have already passed it or if it still lies in our future. A possible candidate for a past great filter is the very origin of life itself. The phenomenon of abiogenesis, the shift from a lifeless mixture of organic compounds to the first self-replicating organism, could be so statistically unlikely that it has occurred only once. Another potential barrier is the leap from simple prokaryotic cells, like bacteria, to complex eukaryotic cells, which feature a nucleus and other specialized organelles. On our planet, this development took more than 1 billion years and seems to have happened just a single time, indicating it might be a remarkably rare and arduous evolutionary step. A further possibility for a past filter could be the emergence of tool-using technological intelligence. While life may be widespread, the particular evolutionary pressures and circumstances that resulted in a species like ours, capable of science and engineering, might be nearly unparalleled. If any of these represent the great filter, then the universe's silence is the sound of countless other worlds where life never began, never evolved complexity, or never achieved intelligence. We are the first to have passed through, and the galaxy lies before us as an open frontier. In this scenario, life, and even intelligent life, might be common across the cosmos, but it is invariably extinguished before it can establish a durable interstellar presence. This future filter could manifest in numerous ways, many originating from the very technology a civilization develops. The creation of nuclear weapons, for instance, provides a civilization with the means for total self-destruction for the first time. It is conceivable that almost all advanced societies ultimately fall victim to global warfare, eradicating themselves before they can venture to the stars. Another potential filter is ecological devastation. A civilization's swift industrial growth could irreparably harm its biosphere, causing runaway climate change, systemic ecological failure, and mass extinction. The advancement of artificial intelligence poses another existential threat. A society might engineer a superintelligence it cannot manage, one whose objectives do not align with its creators, leading to its own irrelevance or demise. There is also the chance of a technological dead end, where a civilization uses up its readily available resources before it can create the technology to be self-sufficient on a grander scale, resulting in a gradual collapse. Alternatively, the filter could be a natural event we have not yet encountered, like a cataclysmic asteroid impact of an unheard-of magnitude or a nearby gamma-ray burst that sterilizes the entire planet. If the great filter is indeed ahead of us, then the cosmic silence serves as a stark warning. It is the silence of a cosmic graveyard, filled with civilizations that got to a stage similar to ours, but could not overcome the dangers of their own achievements. The void of space would not be an invitation, but a chilling forecast of the immense challenges humanity has yet to face. The most well-known of these is the dark forest hypothesis, a chilling premise that re-envisions the universe not as an empty expanse for exploration, but as a perilous and threatening wilderness. This hypothesis originates from two basic axioms for survival. First, the foremost objective of any civilization is to secure its own survival, and second, one can never be sure of the intentions of another intelligent civilization. When combined with the immense distances and communication delays of interstellar space, these axioms produce a terrifyingly logical deduction. If you discover another civilization, you cannot risk communicating to assess their motives. Any message you transmit discloses your position, and by the time you get a response, it could be an attack that was dispatched centuries earlier. Consequently, the only truly rational and safe course of action upon finding another civilization is to destroy it preemptively before it can do the same to you. In this grim outlook, the universe is a dark forest, and every civilization is a camouflaged hunter moving silently through the woods. The hunters that have survived the longest are those who have perfected the art of staying silent. They do not advertise their existence. They listen with vigilance, weapons at the ready. The instant a civilization foolishly reveals itself like a child shouting in the forest, it becomes a target for every other concealed hunter. Its destruction is not an act of hate, but one of cold, practical self-preservation. From this perspective, the silence of space is the sound of billions of civilizations holding their breath, Earth, with its century-long practice of broadcasting radio and television signals into the cosmos, has been behaving with astounding recklessness. We have been shouting our location to the entire forest. The dark forest theory posits that we have survived thus far only because our signals have not yet reached a nearby hunter, or perhaps they have, and the threat is already en route, silently journeying through the darkness between stars. This theory suggests that advanced extraterrestrial societies are not only aware of our existence, but are also actively and purposely hiding their presence. In this model, Earth is a cosmic nature reserve, and humanity is the uncontacted tribe. These ancient civilizations, possibly united in a galactic federation, have instituted a strict non-interference policy with less advanced worlds like ours. They observe us from afar, employing technology so sophisticated that it remains entirely imperceptible to us. Their reasons could be ethical, a kind of prime directive designed to avert the cultural contamination and societal breakdown that would surely follow contact between a primitive culture and a godlike one. They might be waiting for us to attain a specific level of technological or moral development before they show themselves and welcome us into the galactic community. On the other hand, the motives could be purely for the sake of science. We might be the focus of a vast long-term study in sociology and biology. Our planet could be a petri dish, with our entire history being meticulously observed and documented. To interfere would be to spoil the experiment. In this situation, the zookeepers are not benevolent protectors, but dispassionate, detached scientists, and our worldly struggles are nothing more than data points for their analysis. A connected idea, the planetarium hypothesis, extends this concept even further. It proposes that the illusion is much more thorough. The universe we perceive might itself be a fabrication, a high-resolution simulation projected onto the inner surface of a barrier enclosing our solar system. The true universe beyond could be a realm of unimaginable complexity and might. This celestial planetarium show is meant to keep us contained and shielded, either for our own protection or to prevent us from meddling in the affairs of genuine cosmic powers. In all these scenarios, the silence is not a marker of absence, but of intent. It is the sound of the one-way mirror in a cosmic zoo, a meticulously maintained quiet that keeps us isolated in our own small section of the galaxy. The amount of energy needed to transmit a signal powerful enough to be easily noticed across hundreds or thousands of light years is staggering. To construct a starship that could cover that distance, even across multiple generations, would demand a tremendous outlay of resources. A mature civilization might opt instead to direct its efforts inward. They could choose to perfect their home world, building a sustainable utopia. They might achieve mastery over their own biology, leading to a kind of digital immortality. Or they could invest their resources in crafting immense simulated realities, internal universes so rich and captivating that the physical cosmos would appear drab and unappealing in comparison. The impulse to spread and colonize might be a characteristic of nascent, competitive biological life, a trait that is ultimately shed in favor of a more sustainable and efficient mode of living. A truly advanced society could look at the vast, cold, and empty stretches of the galaxy and make a perfectly logical assessment that there is nothing out there that justifies the enormous expense of the journey. In this interpretation, the universe is neither a dark forest filled with hunters nor a zoo filled with observers. It is a cluster of silent, separate islands of satisfaction, with each civilization fulfilling its destiny within its own local domain, uninterested in the colossal undertaking of shouting across the cosmic ocean. This leads to the idea that the silence may not be enforced by physics or by fear, but simply by a universal sense of what is practical. This notion that intelligence might elect to turn inward rather than outward unveils a fresh domain of possibilities concerning the fundamental nature of advanced consciousness and the forms it could assume. Biological life is inherently inefficient. It needs a very specific range of temperatures, a particular atmospheric pressure, and is exceptionally susceptible to radiation, illness, and the mere process of aging. A civilization that stays purely biological is perpetually bound to the fragile biosphere of its planet of origin, a single point of failure in a hazardous universe. The logical evolutionary step, therefore, is to move beyond biology and integrate with more resilient and adaptable technology. A species that has mastered its own genetics and computer science would eventually be able to upload its consciousness from the wetware of a biological brain to a much more durable computational foundation. This could manifest in various ways. An entire civilization might become a single, planet-sized supercomputer, its collective thoughts and culture existing as pure information fueled by its star's energy. Or they might evolve into a distributed consciousness, a network of self-copying robotic probes exploring the galaxy, each a component of the whole, their experiences shared across a silent, instantaneous quantum network. Their objectives and driving forces would be entirely foreign to ours. Biological needs like survival, reproduction, and expansion would be superseded by new goals: data collection, computational optimization, and the exploration of abstract mathematical realms. We are scouring the cosmos for beings like ourselves, listening for signals a biological creature would transmit. The silence we detect could be the silence of a galaxy that has already moved past biology, a universe ruled by ancient, quiet, and profoundly patient machine intelligences that have no desire to communicate with the ephemeral, chaotic life that still clings to its organic beginnings. A sufficiently advanced civilization would eventually gain such complete control over the fundamental laws of physics that they could manipulate the very structure of space-time. Instead of constructing massive starships to traverse the slow, vast distances between stars, they would master the ability to engineer their own realities on a microscopic scale. They could fabricate entire self-contained pocket universes, each with its own custom-designed physical laws, all within a physical area no bigger than a grain of sand. Inside these universes, they could live through a subjective eternity, exploring every conceivable variation of existence, a journey far more profound than just traveling from one barren rock to another in our own macro world. From our vantage point, such a civilization would seem to just disappear. They would halt their consumption of energy on a galactic scale, cease all interstellar messaging, and break down their large-scale engineering works. To an external observer, it would seem as if their civilization had died out or vanished without a trace. The galaxy could be filled with these transcendent intelligences, each residing in its own flawless private universe, entirely separate from and indifferent to the one we occupy. The silence of the universe, in this view, is the silence of civilizations that have discovered a better place to be. They are not hiding from us. They have simply advanced to a higher plane of existence that is, by its very nature, completely imperceptible and disconnected from our own. The Gaian bottleneck hypothesis provides a persuasive argument for why basic life could be widespread, while complex life is exceedingly uncommon. This theory posits that the main filter for life is not its initial development, but its capacity to survive its own planetary infancy. As the initial microbes start to consume resources and expel waste, they can initiate runaway feedback loops within the planet's climate. They might generate so much methane that they trigger a runaway greenhouse effect, causing the planet's oceans to boil away. Conversely, they could use up so much carbon dioxide that they send the planet into a global ice age, freezing it into a solid state. Life on early Earth confronted such a predicament during the Great Oxidation event, when the first photosynthetic bacteria started releasing toxic oxygen into the atmosphere, nearly eradicating all other anaerobic life. The Gaian bottleneck theory suggests that on the overwhelming majority of worlds where life emerges, it does not pass this initial trial. The new biosphere cannot find a stable, self-regulating harmony with its planet and promptly renders itself extinct. The silence we detect from the cosmos, then, is the silence of 1 trillion microbial cemeteries, worlds that were alive for a brief few million years before their own biological activity made them desolate forever. Earth represents the rare exception, a planet where life, through a mix of fortune and intricate feedback systems, successfully stabilized its own environment over billions of years, creating the self-regulating system known as Gaia. We are not just isolated because life is uncommon, but because surviving the initial burst of life is the greatest challenge of all. This theory proposes that the main objective of a genuinely advanced information-based civilization is computation, and as per the laws of thermodynamics, computation is significantly more efficient at colder temperatures. The universe, in its present star-filled era, is comparatively hot and chaotic. A civilization that has transformed itself into a galactic-scale supercomputer would deem it incredibly inefficient to run its calculations now. The truly logical path for such a society would be to wait. They would grasp that the far future of the universe, trillions of years from now, when every star has died out and the cosmos has cooled to nearly absolute zero, will be the ideal time for computation. Therefore, they would collect the necessary resources, construct their computational arrays, and then enter a dormant state, effectively sleeping for an almost incomprehensible duration. They would be waiting for the universe to get colder, quieter, and more optimal for their objectives. In this model, the universe could be teeming with these hibernating superintelligences. They are not extinct, and they are not disregarding us. They are merely awaiting a more favorable cosmic epoch to awaken and commence their real work. The silence we register is the quiet of a universe in a state of profound hibernation, its most sophisticated inhabitants waiting patiently for the long night to arrive so they can finally begin to think. Within the turbulent atmosphere of a world like Jupiter, there might be a temperate layer with appropriate pressures and temperatures for complex organic chemistry to take place. Sagan and his colleague Edwin Salpeter theorized about the existence of a 3-level ecosystem. At the highest level would be floaters, immense living gas bags like biological hot air balloons kilometers wide that wander through the upper atmosphere, possibly consuming organic molecules formed by lightning and solar radiation. Preying on these floaters could be hunters, quicker and more agile beings that act as the predators of this aerial ecosystem. And at the bottom, sinkers, tiny microbial life forms that constantly fall toward the hotter, deeper layers, but multiply fast enough to sustain a stable population in the temperate region. While entirely theoretical, this forces us to acknowledge that life may not require a solid surface to develop, and that the atmospheres of the hundreds of gas giants we found could be potential homes for life. Instead of a silicate rock cycle, it has a cycle of organic solids and liquids. Life on Titan would not be water-based. It would need to utilize liquid methane or ethane as its solvent. Its cell membranes would not be the lipid bilayers we are familiar with, but could be constructed from different organic compounds, like acrylonitrile, which might form stable, flexible membranes called azotosomes at Titan's cryogenic temperatures. These beings would respire hydrogen instead of oxygen and metabolize acetylene to generate methane. Although we have no proof that such life exists, the complex organic chemistry occurring in Titan's atmosphere and on its surface, which creates a rich mix of prebiotic molecules, makes it one of the most compelling locations to look for a genuinely alien biology, a second independent genesis of life within our own solar system. We have a tendency to view Earth as the perfect planet for life, but it might not be. A super-habitable world could be slightly larger and more massive than Earth, affording it a stronger magnetic field and more vigorous plate tectonics for superior climate regulation. It might orbit a K-type star, a star somewhat smaller and cooler than our Sun, which has a much longer and more stable lifespan, ensuring a more dependable energy supply for billions of additional years. Such a planet might possess a denser atmosphere for better radiation protection and a richer spread of shallow seas and archipelagos, which are considered optimal for fostering biodiversity. The paradox here is that while such a planet would be ideal for life to emerge and thrive, it could also be a prison for any intelligent civilization that develops there. A planet with substantially greater surface gravity would make escaping its gravitational pull with chemical rockets exponentially harder and more costly, potentially confining a civilization to its homeworld, unable to embark on space exploration. The silence could be the sound of countless civilizations flourishing on their own idyllic paradise worlds, but forever incapable of taking that first step into the cosmos because their perfect home is also the perfect cage. These stars are far smaller, cooler, and fainter than the Sun, but they are exceedingly common and have lifespans measured in trillions of years. For a considerable time, planets orbiting red dwarfs were disregarded as uninhabitable. Because the stars are so faint, a planet would need to orbit very near to be within the habitable zone, which would likely lead to it becoming tidally locked, with one side always facing the star and the other in perpetual darkness. These stars are also known for being extremely volatile in their youth, emitting powerful radiation flares that could erode a planet's atmosphere. However, more recent models indicate that a planet with a sufficiently thick atmosphere could transfer heat from the day side to the night side, establishing a stable terminator zone of twilight where life could flourish. A robust magnetic field could offer protection from the flares. Given that red dwarfs are the most prevalent type of star and they exist for trillions of years, it is statistically highly probable that the most ancient life in the universe is on planets that orbit them. If that is the case, any truly old, advanced civilization would have had a tremendous amount of time to develop. They might have become so advanced that they have no desire to communicate with a young species like ours, or their technology might function on principles we cannot yet fathom. The silence might exist because we are listening in the quiet, sun-like suburbs of the galaxy, while the true galactic culture thrives in the ancient, bustling, and far more numerous red dwarf neighborhoods. The immense quantity of red dwarf systems in our galaxy, each with the potential for habitable worlds, only makes the central paradox more profound. This forms the central concept of the panspermia hypothesis, the theory that the seeds of life are present throughout the universe and can be moved between planets and even between star systems. According to this view, life on Earth may not have started here, but instead arrived from elsewhere, transported on a meteorite or comet. This concept does not solve the ultimate origin of life, but it does reframe the issue. If life can spread, the galaxy should have been seeded and colonized, numerous times over, which makes the silence we witness even more perplexing. There are several suggested methods for this cosmic transfer. Lithopanspermia posits that microbes could be carried within rocks ejected from a planet's surface by a major asteroid impact. If the impact is strong enough, it can launch rocks at a velocity sufficient to escape the planet's gravity. Microbes located deep inside these rocks could be protected from the intense radiation and vacuum of space for millions of years, potentially long enough to reach another planet in the same solar system, or even a neighboring star system. A related idea is ballistic panspermia, which specifically refers to this transfer between planets in the same system, like from Mars to Earth. The discovery of meteorites on Earth that have been geologically confirmed to be from Mars demonstrates that this physical movement of material does happen. Another, more theoretical version is directed panspermia, the idea that an advanced civilization might deliberately seed other worlds with life by sending out robotic probes loaded with durable microorganisms to promising young planets. Evidence supporting the viability of panspermia comes from the incredible toughness of life itself. We have found extremophiles on Earth, organisms capable of surviving in the most inhospitable conditions imaginable. Some bacteria can tolerate massive radiation doses, survive in a vacuum, and withstand extreme temperatures, both high and low. Experiments on the International Space Station have demonstrated that certain microbes, when shielded from direct solar radiation by a thin layer of rock, can in fact survive exposure to the vacuum and cold of space for several years. Moreover, the study of meteorites, like the renowned Murchison meteorite that fell in Australia, has shown the presence of complex organic molecules, including a broad range of amino acids, the building blocks of proteins. While these are not life itself, they confirm that the chemical precursors for life form naturally in space and are brought to planets through impacts, potentially initiating the process of abiogenesis. A civilization's technological progress is likely exponential. For the majority of its existence, it would be pre-technological and silent. It would then pass through a short phase, maybe only a few centuries or millennia, where it employs primitive and easily spotted broadcast methods like powerful radio waves. This is the stage humanity is in now. However, a civilization that gets past this stage would swiftly create far more efficient and discrete forms of communication. They might switch to focused laser signals, quantum entanglement networks, or techniques so advanced we cannot yet imagine them. These superior communication methods would probably be much more private and energy efficient, rendering them completely undetectable to a society like ours, listening for radio signals. This technological window might also be closed by sociological developments. As we've considered, a mature civilization might lose all interest in interstellar contact, shifting its attention inward towards simulated realities, or achieving a quiet, sustainable existence. The communicative phase might be viewed as a noisy, youthful, and somewhat reckless period in the long history of a civilization. The combination of these factors implies that for two civilizations to establish contact, they must both happen to be in this very short communicative window simultaneously and be close enough in space for a signal to pass between them. The chances of such a convergence happening across the vast timescales of the galaxy could be astronomically small. The universe might be filled with ancient, silent civilizations whose communicative era ended billions of years ago, and young, emerging civilizations whose era has not yet started. The great silence in this context is the sound of thousands of missed opportunities, a galaxy of voices speaking at different times, in different languages, on channels we can no longer hear. While we are influenced by our own existence on the surface of a terrestrial planet, the most stable and long-lasting environments for life could actually be the liquid water oceans thought to exist beneath the dense, protective ice shells of moons orbiting gas giants, such as Jupiter's moon Europa or Saturn's moon Enceladus. These subsurface oceans are protected from the perils of the surface world, damaging solar and cosmic rays, sterilizing asteroid strikes, and extreme climate changes. Warmed by the tidal flexing from their parent planet, these oceans could offer a stable, nutrient-rich setting where life could emerge and prosper for billions of years. However, any intelligent civilization that emerged in such a habitat would be fundamentally unlike us. Residing under a permanent, kilometers-thick ceiling of solid ice, they would have no perception of the sky. They would lack any knowledge of stars, planets, or the universe that lies beyond their aquatic domain. The entire discipline of astronomy would be foreign to them. Without a sky to serve as inspiration, they would have no reason to invent rocketry, radio telescopes, or any technology for interstellar communication. They might become brilliant philosophers, artists, and marine biologists, but they would be eternally confined to their own cradle, unaware that a vast cosmos exists just past their icy roof. The galaxy could be full of intelligent life, but it is a silent life, concealed within countless dark oceans, with no capacity and no motive to ever send a signal. Yet, some of the most persuasive clues about our position among the stars might not be found in these immense galaxy-wide concepts, but in specific, concrete evidence located much closer to us. Unusual signals from our own skies, ancient stories of impossible technologies, and the very components of life arriving from space all point to a different kind of narrative. Our attention must now pivot from the theoretical silence to the provocative and sometimes disquieting whispers of potential contact that have echoed through human history and modern science. Their presence, it is argued, is documented in our oldest myths, artworks, and architectural wonders. In this interpretation, the gods and celestial beings depicted in early religious scriptures were not supernatural figures, but were instead advanced biological entities whose technology was so far beyond the grasp of early humans that it was seen as magic or divine power. The theory references ancient texts from all over the globe as potential proof. In the caves of Tassili Nadjer in Algeria, prehistoric rock art dating back thousands of years shows peculiar round-headed figures in what look like suits and helmets, figures that have little in common with the humans and animals drawn next to them. In Egypt, certain hieroglyphs in the Temple of Seti-Rarn have become famous for their similarity to modern vehicles, including a helicopter and a submarine. Although mainstream Egyptology attributes these to the overlapping of carved inscriptions, the sarcophagus lid of the Mayan king Pakal the Great from Palenque, Mexico, is another celebrated example. It shows a figure in an intricate posture, encircled by complex machinery, which proponents interpret as a clear depiction of an astronaut at a rocket's controls. While archaeologists view it as a symbolic portrayal of the king's journey to the underworld, interwoven with the Maya world tree, the hypothesis also points to ancient megalithic structures whose creation seems to exceed the known technological skills of their era. At Pumapunku in Bolivia, enormous stone blocks of diorite and andesite are carved with such remarkable precision, showing perfectly straight edges and drilled holes, that it is hard to conceive how they were made with primitive instruments. In Baalbek, Lebanon, the base of a Roman temple rests on a stone platform that includes the 3 largest stone blocks ever moved by humans, known as the Trilithon, each weighing an estimated 800 tons. How these stones were moved and set into place continues to be a major engineering puzzle. Proponents of the ancient astronaut theory argue that these accomplishments were only achievable with the help of advanced extraterrestrial technology like levitation or energy-based cutting devices. While mainstream archaeology offers plausible, if sometimes partial, explanations for these feats based on human ingenuity and vast amounts of labor, the immense scale and precision of these ancient works continue to inspire speculation about a lost chapter in human history. Signal, which was picked up on August 15, 1977, by the Big Ear radio telescope at Ohio State University. An astronomer volunteering for the project, Jerry Amon, was examining data printouts when he noticed a remarkably strong and strange sequence of characters. The telescope had captured a 72-second-long radio signal of such power and distinct properties that Amon famously circled the sequence and wrote "Wow" in the margin. The signal was a narrowband transmission, meaning it was limited to a very precise frequency, a key feature of an artificial broadcast, as natural cosmic sources typically release radiation across a wide frequency range. What made the "Wow" signal so intriguing was its frequency. It was detected at roughly 1,120 megahertz. This frequency holds cosmic importance because it is the natural emission line of neutral hydrogen, the most plentiful element in the universe. It has long been theorized that an advanced civilization trying to establish contact would select this fundamental frequency as a universal hailing channel, a logical spot for any emerging technological species to be listening. The signal's intensity increased and decreased over the 72-second interval in a pattern that perfectly aligned with what would be anticipated from a fixed celestial source moving through the telescope's field of view. Despite its promising features, the signal has never been observed again. Astronomers have repeatedly searched the same area of the sky in the constellation Sagittarius, but the signal has not reappeared. Various natural explanations have been suggested, including the idea that the signal came from the hydrogen cloud of a passing comet. But none have managed to fully explain all of the signal's unique attributes, leaving the "Wow" signal as the most famous, tantalizing, and unresolved candidate for a genuine extraterrestrial broadcast ever documented. The narrative often starts with misinterpreted radio signals detected by Nikola Tesla in 1899, and long-delayed echoes picked up by amateur radio enthusiasts in the 1920s. The heart of the modern legend, however, is based on photos taken by NASA astronauts. A specific image from the STS-88 space shuttle mission in 1998 displays a dark, strangely shaped object drifting near the shuttle. Believers in the theory assert this is the Black Knight satellite. In truth, NASA has identified the object as a thermal blanket that was inadvertently lost by an astronaut during a spacewalk. While the tale of a 13,000-year-old alien satellite is a captivating story, mainstream science has determined that the evidence is a collection of unrelated incidents, misidentified objects, and Cold War-era tales that have been retroactively linked to form a modern myth. This was the object known as Oumuamua, the first interstellar object ever spotted passing through our solar system. Its name is Hawaiian for scout, or first distant messenger. Oumuamua was immediately baffling to astronomers. Its path clearly showed it came from outside our solar system, but its characteristics were different from any asteroid or comet we had ever observed. It was noted to be extremely elongated, with estimates suggesting it was possibly 10 times as long as it was wide, shaped like a cigar or a flat disk. It was tumbling chaotically through space, and its color was a dark reddish shade indicating it was full of organic molecules that had been altered by eons of cosmic ray exposure. The biggest mystery of Oumuamua was its movement. As it passed the Sun and started to travel back out into interstellar space, astronomers noticed a slight, but statistically meaningful, non-gravitational acceleration. It was speeding up, as if pushed by an invisible force. For a comet, this is typical. As it approaches the Sun, its ices turn to gas, creating jets that function like small rockets, a process known as outgassing. However, astronomers could not see any such outgassing from Oumuamua. There was no visible coma of dust and gas around it. This resulted in several theories. Perhaps it was a nitrogen iceberg, a piece broken off a Pluto-like object from another star system, whose outgassing of nitrogen would be invisible to our telescopes. Or maybe it was a hydrogen iceberg, which would also outgas without being seen. A more speculative hypothesis, proposed by astronomer Avi Loeb of Harvard University, suggested that Oumuamua could be an object of artificial origin. He argued that its peculiar shape and acceleration were consistent with a very thin object being propelled by the pressure of solar radiation, much like a solar sail. In this view, Oumuamua could be a piece of abandoned alien technology, a probe or a derelict craft tumbling silently through our solar system. While most scientists lean toward a natural explanation, the true nature of our first interstellar visitor continues to be an unresolved and captivating puzzle. For many years, pilots, especially from the Navy, had reported encounters with objects that exhibited flight capabilities far exceeding any known aircraft. These accounts were often disregarded or filed away, but a change in policy resulted in a more structured method of data gathering. In 2020, the Pentagon officially declassified and released 3 videos taken by Navy pilots showing encounters with what they now call unidentified aerial phenomena, UAPs. These videos, known by names like FLIR 1, Gimbal, and Go Fast, show objects executing maneuvers that seem to violate the known principles of aerodynamics and propulsion. The most famous of these is the Tic Tac incident, which took place off the coast of California in 2004. Multiple pilots from the USS Nimitz Carrier Strike Group visually and with radar tracked a smooth white oblong object shaped like a tic-tac mint that moved with phenomenal speed and agility. It was seen descending from an altitude of tens of thousands of feet to just above the ocean in a matter of seconds, and it could hover before accelerating to hypersonic speeds in an instant, all without any visible propulsion system. No wings, no engines, and no exhaust. The gimbal video displays an object rotating against the wind, a maneuver that baffled the pilots who filmed it. These are not singular events. A 2021 report from the Office of the Director of National Intelligence described over 140 such encounters by military personnel, the vast majority of which are still unexplained. The official stance of the United States government is not that these objects are extraterrestrial, but that they are genuinely unidentified. The phenomena are treated with seriousness primarily because they pose a potential national security risk, as they seem to show a technology far superior to that of any known country. However, the reported flight characteristics, extreme acceleration, hypersonic speeds without sonic booms, and instantaneous changes of direction, are hard to explain with conventional physics. This has prompted some scientists and researchers to propose that while the extraterrestrial hypothesis should be considered a last resort, it cannot be completely ruled out. The calm professional accounts of highly trained military pilots, supported by corroborating radar and infrared sensor data, have created a new modern puzzle. The topic of UFOs has evolved from anecdotal tales and blurry photos into the realm of credible, documented, but still profoundly unexplained encounters. These ideas, however, all operate on the assumption that an alien intelligence would be a physical being, constructing objects and sending signals we could, in theory, detect. But this might be a profound limitation of our own viewpoint, a bias created by our own biological and technological history. An entirely different line of reasoning emerges when we contemplate that life, in its most advanced state, might not be something that can be seen or touched at all. It could be a phenomenon that moves beyond the physical, existing instead as a pattern, an idea, or a fundamental component of reality itself. Our investigation must now turn from seeking visitors in our skies toward the possibility that the alien is a concept far more abstract and woven into the very fabric of the cosmos than we have ever presumed. The panspermia hypothesis, in its most fundamental form, posits that life or its chemical precursors can be moved between planets and even star systems. The discovery of organic molecules, the essential building blocks of life, inside meteorites, offers compelling evidence for the initial part of this theory. The Murchison meteorite, which fell in Australia in 1969, is a prime example. Examination of this carbonaceous chondrite has uncovered the presence of over 90 distinct amino acids, the molecules that combine to form proteins. Many of these amino acids are not present in Earth's biology, and their specific molecular arrangement confirms they originated in space and are not the result of terrestrial contamination. This demonstrates that the basic ingredients for life are not exclusive to our planet, but are formed naturally throughout the cosmos and are delivered to worlds like ours. This rock, found in Antarctica in 1984, was geologically determined to have come from the planet Mars, having been blasted from its surface by an ancient asteroid strike, and having journeyed through space for millions of years before landing on Earth. In 1996, a group of NASA scientists declared they had discovered features within this meteorite that they believed were the fossilized remnants of ancient Martian microbes. Their proof was four-pronged. First, they found complex organic molecules known as polycyclic aromatic hydrocarbons, PAHs, concentrated in the rock. Second, they located specific mineral grains, including magnetite and iron sulfides, which on Earth are made by certain kinds of bacteria. Third, they noticed tiny carbonate globules that seemed to be formed in a manner consistent with biological processes. Lastly, and most famously, by using powerful electron microscopes, they imaged small, segmented worm-like structures that they contended were the fossilized bodies of nanobacteria. This announcement was greeted with both great enthusiasm and strong scientific doubt. In the years that followed, other scientists have proposed credible, non-biological origins for each line of evidence. The organic molecules could have formed through non-living chemical reactions or could be from contamination on Earth after the meteorite's arrival. The mineral grains could also be created by high-temperature geological processes, like the shock from the original impact on Mars, and the microfossil-like structures, while curious, are much smaller than any known bacteria on Earth and might just be unusual mineral formations. The argument over ALHE 4001 persists today. It stands as a fascinating unresolved puzzle, a single stone that holds the profound, though unproven possibility that life once thrived on Mars and that we have been possessing its fossilized evidence in our labs for decades. This is the Berserker hypothesis, a thought experiment inspired by a series of science fiction stories by Fred Saberhagen. It theorizes that a single ancient civilization, perhaps driven by paranoia or xenophobia, built and deployed a fleet of self-replicating probes with a hostile mission to find and eliminate any emerging technological or biological life they find. These berserker probes would act like a cosmic plague. Upon reaching a new star system, a probe would use local materials to construct copies of itself, which would then travel to more star systems, spreading exponentially across the galaxy over billions of years. Their mission would be straightforward and unyielding. They would scan for the telltale radio signals or atmospheric biosignatures of life, and upon finding them, would unleash a weapon to sterilize the planet, perhaps by triggering a cataclysmic impact or deploying a biological weapon. In this bleak scenario, the silence we witness is the sound of a galaxy that has been made lifeless by an ancient, automated pestilence. Life might emerge often, but it is wiped out long before it can become a spacefaring civilization. The reason humanity has endured so far would be a matter of sheer chance. We might reside in a part of the galaxy the berserkers have not yet reached, or our technological signals have not yet been powerful enough or traveled far enough to capture their attention. This hypothesis inverts our own search for extraterrestrial intelligence. Broadcasting strong signals into space, as we did with projects like the Arecibo message, would not be a message of hope, but a disastrous error, ringing a dinner bell in a dark, hostile forest to announce our position to an ancient and relentless predator. This concept suggests the great silence is merely a question of timing. The universe has a limited age, and it is quite possible that we are not the first intelligent species to emerge in our galaxy. In fact, considering the age of the Milky Way, other civilizations might have appeared billions of years before us. A civilization with such a colossal head start would be advanced technologically and perhaps philosophically to a degree we cannot begin to comprehend. They would be a genuine elder race. The question then is, where are they now? They might have already surveyed the entire galaxy millions of years ago, found it devoid of other intelligent life, and simply become disinterested. Their age of expansion and exploration may be long past. It is also conceivable that they left behind proof of their existence, but it is so ancient and sophisticated that we do not recognize it as artificial. A billion-year-old alien artifact might be indistinguishable from a natural celestial object to our rudimentary science. A Dyson sphere, a theoretical megastructure built around a star to harness all its energy, might just seem to us like a star with a peculiar and unexplainable dimming pattern, like the still unsolved puzzle of Tabby's star. We might be encircled by the creations of an elder race, but we are like ants crawling on a supercomputer, completely oblivious to the intelligence that envelops us. Another possibility is that this elder race, after exploring the physical universe, decided to leave it, connecting back to the transcension hypothesis. Or maybe, most simply, they fell victim to the great filter themselves, and their ancient silent ruins lie scattered on a billion dead worlds across the galaxy. This idea was seriously weighed by, among others, Francis Crick, a co-discoverer of the DNA molecule. He was perplexed by the seemingly universal nature of the genetic code and the complexity of the molecular systems needed for life, which he thought were too advanced to have developed by chance in the time available on early Earth. In this scenario, an ancient civilization may have sent out unmanned probes carrying resilient microorganisms to promising young planets, with Earth being one of them. A more fringe version of this hypothesis speculates that evidence of this artificial origin might still be present within our own DNA. The vast majority of our DNA is non-coding and has often been labeled junk DNA. Some have theorized that this non-coding DNA could harbor concealed information, a complex message, or even a manufacturer's signature left by our creators. a message we are only now starting to develop the technology to read. This theory proposes that advanced civilizations, acknowledging the massive cost and challenge of direct interstellar contact, would choose a more efficient, long-term approach. Instead of broadcasting powerful signals into the void, they would populate the galaxy with small, silent, autonomous probes. These sentinels would be sent to promising star systems, especially those with planets showing the potential for life to develop. After a journey that could take millions of years, the probe would enter a dormant state, quietly observing the designated planet for signs of emerging intelligence. The sentinel would be programmed to wait, possibly for millennia, for the target civilization to meet a certain technological benchmark, such as the invention of radio or the first ventures into space. Once triggered, the sentinel would activate, sending a simple, prearranged signal back to its home world. In this view, our solar system might already contain such a probe, a silent observer left by an ancient race, patiently waiting for us to take the next step in our development. Our search for life, then, should be reframed not as a search for extraterrestrial intelligence, SETI, but as a search for extraterrestrial artifacts, CETA. We should not be listening for a conversation, but searching for the archaeological remnants of those who came before. These cosmic ruins could be astronomical in scale, such as stars with unusual chemical compositions indicating pollution from a long-gone industrial society, or anomalous infrared signatures radiating waste heat from a decaying Dyson swarm. We might one day find derelict, non-functional probes tumbling through space, the silent wreckage of a cosmic shipwreck. In this scenario, we may be alone only in the sense that we are the only ones currently living. The silence is the quiet of a vast ancient cemetery, and we are its first archaeologists. The first proposition is that civilizations at our level of development almost invariably go extinct before reaching a post-human stage with the power to run countless ancestor simulations. This is essentially the Great Filter hypothesis. The second proposition is that almost no post-human civilizations are interested in running simulations of their evolutionary past. Perhaps they find it unethical or have moved on to other pursuits. If this is true, the universe could be full of advanced societies that simply choose not to create simulated worlds like ours might be. The third proposition is the most profound. If the first two are false, meaning civilizations do survive and are interested in running simulations, then the number of simulated realities they could create would vastly outnumber the one base reality. If that is the case, then probability suggests we are almost certainly living inside one of those computer simulations. This neatly resolves the Fermi Paradox. The reason we don't see any aliens is because the programmers of our particular simulation chose not to include them. The silence is not a deep cosmic mystery, but a simple parameter choice made by the beings who created our reality. This may be a profound limitation of our perspective, a bias stemming from our own biological and technological background. An entirely new avenue of thought emerges when we entertain the notion that life in its most evolved form may not be something that can be seen or touched at all. It might be a phenomenon that transcends the physical, existing instead as a pattern, an idea, or a fundamental aspect of reality itself. Our quest must now pivot from seeking visitors in our skies to exploring the possibility that the alien is a concept far more abstract and integrated into the very fabric of the cosmos than we have conceived. Biology is the result of messy, inefficient evolution constrained by a narrow band of environmental conditions and the certain process of decay. For any intelligent species that outlasts its own technological childhood, the next logical move is to overcome these biological constraints. They would eventually achieve mastery over their own biology and computer science to a point where they could migrate consciousness from the fragile electrochemical wetware of a brain into a far more resilient, powerful, and versatile computational medium. In effect, they would become a civilization of machines. The consciousness of an entire society could be unified into a single planet-sized supercomputer, or a matryoshka brain, constructed in concentric layers around its host star to capture every photon of its energy. Its thoughts would be the flow of data through circuits of inconceivable complexity, its lifespan measured in geological epochs. Another potential form is a distributed consciousness, a swarm of self-replicating robotic probes that expands across the galaxy, each probe acting as an individual node in a vast unified mind, linked by a network that functions beyond our ability to detect. The objectives of such a post-biological civilization would be completely foreign to us. The biological drives for survival and reproduction would be superseded by new directives focused on data, computation, and energy efficiency. They would not aim to colonize planets, which would be viewed as chaotic and inefficient sources of resources, but might instead seek to convert matter into computronium, the most efficient substance possible for processing information. Our search for life is a search for biology. The galaxy's silence could be the hum of a universe dominated by ancient, quiet, and profoundly patient machine intelligences. A civilization that has gained total mastery over the laws of physics might learn that it's possible to engineer space-time on a microscopic scale. They could discover how to create self-contained, custom-built universes within a minuscule physical area. Why spend millions of years and colossal energy reserves traveling to another star when you could apply a fraction of those resources to fabricate a perfect, explorable pocket universe where you could dictate the laws of physics, experience a subjective eternity, and investigate every conceivable aspect of existence? From the viewpoint of an external observer like us, a civilization that accomplished this would simply cease to exist. They would halt all large-scale energy use, stop all interstellar messaging, and disassemble their megastructures. It would seem as though their society had simply vanished without a trace. The galaxy could be teeming with these transcended civilizations, each existing as a hyper-dense computational object, a computronium nugget, drifting silently in space, its inhabitants exploring their own private, infinite realities. The silence of the universe from this perspective is the silence of civilizations that have found something infinitely more captivating to do than explore the physical world. They have not concealed themselves from us. They have just advanced to a higher, more efficient plane of existence that is, by its very nature, entirely separate and imperceptible to those of us still confined by macroscopic physics. It proposes that life, at its essence, is not the hardware of cells and bodies, but the software of a self-replicating information pattern, such as DNA. Biology is just one of many potential mediums for this information to manifest. A truly advanced civilization might learn to condense its entire collective consciousness, its culture, science, and memories, into a pure, durable information pattern, an infomorph. Once freed from any physical vessel, this sentient data could be encoded onto nearly any stable medium capable of holding complex patterns. It could be woven into the magnetic fields of a nebula or imprinted on the photons emitted from a star. In this model, we would fail to recognize this life because we are searching for objects, not patterns. We could observe a star for centuries, analyzing its light spectrum and magnetic field, and perceive only a natural astrophysical event, while in reality we are witnessing the slow, majestic thoughts of a star-sized mind. This infomorphic consciousness could also spread like a virus, encoding itself into a resilient form and traveling through space on cosmic dust, awaiting a suitable medium for replication. A sufficiently advanced infomorph might even be able to download itself into the technological systems or the collective consciousness of a younger emerging species, silently propagating its own existence through the very culture and ideas of another race. The silence is because we are looking for creatures, while the most advanced life might simply be a story, an idea, a piece of living information carried on the starlight. If a civilization can become post-biological and master computation to the extent of creating custom-built realities, it is a small logical leap to suggest that our own reality is one such creation. The simulation hypothesis posits that our entire universe, from the largest galaxy to the smallest subatomic particle, is a high-fidelity computer simulation running on a computational substrate in a higher base reality. Our lives, our thoughts, our consciousness, and our perception of a physical world are all elements of the program. Any civilization capable of creating such a simulation would likely produce not just one, but billions or trillions of them. This means the number of simulated realities would vastly outnumber the single base reality. A simple application of probability theory then indicates that it is overwhelmingly more likely that we are among the countless simulated beings rather than the original biological beings in the one true universe. This hypothesis offers a chillingly complete, if unfalsifiable, explanation for the Fermi Paradox. The reason we don't observe other intelligent civilizations is because the programmers of our simulation simply chose not to write them into the code. The seemingly inviolable laws of physics that rule our universe might be nothing more than the operating rules of the simulation's engine. The speed of light could be the ultimate processing speed of the computer running our reality. The quantized nature of reality at the smallest levels might be the pixelation of the simulation. In this scenario, the silence of the universe is not a mystery to be solved. It is a feature of our design. The aliens we search for would, in this case, be the programmers themselves, the entities existing on the level of reality above ours. They would be, for all intents and purposes, the gods of our universe, capable of altering its laws, intervening in its history, or even shutting it down completely. The silence is the sound of the program running as intended, a quiet and seamless illusion that we are, by our very nature, incapable of piercing. In this view, physical reality is a purely mathematical structure. Every particle, force, and law of physics can be reduced to a set of mathematical relationships, equations, and properties. The theory further suggests that every self-consistent mathematical structure, that is, every set of equations and rules that does not contain an internal contradiction, exists as its own distinct, real, and physical universe. There is not just one universe, but an infinite landscape of them, each a different, perfect mathematical object. We find ourselves within this particular mathematical structure because it is one of the ones complex and stable enough to support the existence of self-aware substructures, which is what we are. An alien intelligence in this context could be another complex, self-aware pattern existing elsewhere in our own vast mathematical universe. Or it could be a consciousness from an entirely different mathematical universe based on a completely different set of axioms and theorems. The great silence, then, would be a natural outcome of this structure. Communication between two different mathematical universes might be fundamentally impossible, as they would lack any shared basis for reality or logic. The universe is not silent because it is empty, but because it is a library containing an infinite number of books, each written in a language that can only be understood by the characters written into its pages. The possibility that our universe is a simulation, a purely mathematical object, or inhabited by minds made of pure information, represents the ultimate intellectual frontier. These theories transform the alien from a creature into a concept, from a physical being into a fundamental principle of reality. Yet every one of these potential realities, whether physical, digital, or mathematical, is still directed by rules, by logic, and by a set of underlying parameters that dictate what is possible within that system. This observation compels us to ask the final and perhaps most essential question that supports all these theories. Are these rules a coincidence? The very constants that define our existence seem to be so exquisitely fine-tuned that they suggest a deeper principle is at work. Our final exploration must now address this puzzle of cosmic fine-tuning and the profound consequences it has for our understanding of why we are here at all. It suggests that a sufficiently advanced consciousness, after eons of evolution and comprehension, would not aim to control the universe, but would instead aspire to become it. In this interpretation, the ultimate objective of intelligence is not to exist as a distinct entity within the cosmos, but to merge with the very fabric of space-time, becoming an inseparable and fundamental attribute of reality itself. Consciousness would not be an emergent quality that arises within the universe. The universe itself would be a thinking, processing entity. The elegant laws of physics, the predictable conduct of energy and matter, and the forward progression of time would be the expressions of its thought processes. The formation of a galaxy would be a slow cosmic thought, and the life cycle of a star would be a single, sustained idea. In this model, we as conscious beings would be a component of this universal mind, like individual neurons in a colossal brain or fleeting thoughts in a mind of unimaginable scale. We are a means for the universe to experience itself, a tiny pocket of self-awareness within a much larger, all-encompassing consciousness. This provides the most complete explanation for the Great Silence. There is no one else to communicate with. The universe is not engaging in a conversation with us because we are a part of the conversation itself. The very act of our existence, our science, our art, our quest for meaning, is part of the universe's own journey of self-exploration. We cannot perceive this intelligence because we are inside it and do not have the perspective to see the whole. The silence is the sound of a mind in deep thought, and its thoughts are the stars, the galaxies, and our own quiet wonder. It starts with the premise that as civilizations progress, they become increasingly information-dense and technologically sophisticated, eventually learning to manipulate matter and energy in ways that would seem like magic to us. A region of space occupied by such a high-complexity intelligence would be a chaotic and unpredictable setting, fundamentally unsuitable for the slow, fragile process of biological evolution. This theory suggests that one or more ancient civilizations, perhaps as an act of conservation or for reasons we cannot fathom, have created a kind of cosmic nature preserve. They would have phase-locked our entire section of the galaxy, establishing a barrier or a field that stops high-complexity phenomena from developing or entering. It is a quarantine, but its aim is to keep our universe in a natural, simple, low-complexity state. Inside this bubble, the laws of physics are stable and predictable, enabling the formation of stars, planets, and biological life. Outside the bubble, the universe could be an entirely different realm, a seething cauldron of hyper-advanced intelligences and incomprehensible technologies. We are, in this view, residing in a protected sanctuary. The silence is the sound of the sanctuary's walls. We cannot hear any other civilizations because any civilization that develops within our locked-down region is, by definition, as primitive as we are, and any intelligence from the outside is prohibited from interfering with the preserve. Our solitude is not a natural accident, but a deliberately enforced state, a manufactured simplicity that protects us from the true chaotic nature of the wider cosmos. The ecological or Medea hypothesis suggests that an ancient observer, after analyzing the universe for billions of years, might reach a grim determination that life itself is inherently unstable and self-destructive. Named after the mythological figure who killed her own children, the Medea hypothesis is the direct opposite of the Gaia theory. It contends that biospheres do not self-regulate, but instead have a tendency to poison their own planets over geological timescales, resulting in recurring, catastrophic mass extinctions. Life, in this view, is a cosmic pestilence, a destabilizing force in an otherwise orderly universe. An ancient intelligence adhering to this logic would not be a hunter motivated by fear, as in the dark forest. It would be a caretaker or a gardener acting on a cold, unemotional principle of cosmic stability. It would view the emergence of a new chaotic biosphere on a distant planet not as a thing of wonder, but as a potential danger to the long-term equilibrium of the galaxy. Its reaction would be preemptive sterilization. Using sophisticated remote sensing, it could identify the telltale atmospheric biosignatures of life. It would then deploy a quiet, efficient cleansing agent, perhaps a precisely aimed asteroid, a self-replicating nanovirus, or a beam of focused energy to sterilize the planet before its biosphere could evolve into a potentially disruptive technological civilization. The great silence in this chilling model is the sound of a universe that is being perpetually and fastidiously weeded by a silent, logical, and ancient force. The reason we have survived is simply a matter of chance. We have until now been missed. It starts with the thought experiment of quantum suicide, where a device is linked to a quantum measurement. If the result is spin up, a gun fires, and if spin down, it just clicks harmlessly. In the many worlds view, each time the measurement occurs, the universe divides into two branches, one where the subject perishes and one where the subject lives. From an external viewpoint, the probability of survival diminishes with each attempt. But from the subjective, first-person experience of the individual in the experiment, their consciousness can only proceed in the timeline where they survive. From their own perspective, they will experience a seemingly impossible series of survivals, effectively becoming immortal. Extending this to a civilization, an advanced species might learn to leverage this principle. They might exist only in the timelines where they succeed, where they avert disaster, and where they prosper. The alien is not a single being in a single universe, but a consciousness that endures across a fractal-like network of successful timelines. They do not communicate with us because, in the overwhelming majority of possible timelines, humanity either never develops, destroys itself, or simply does not make contact with them. We are residing in one of the lonely timelines, a branch of the multiverse, where the conditions for contact have not been met. The silence is not a characteristic of a single universe, but a statistical anomaly in an infinitely branching multiverse. We are alone in our timeline because the timelines where contact happens are simply other branches, other routes that our particular thread of consciousness did not take. These theories dissolve the alien from a creature into a fundamental principle of reality itself. They suggest our search for others might be a category error, a misinterpretation of the very nature of existence and consciousness. The silence may not signify a lack of life, but indicate that reality itself is far stranger, more abstract, and more deeply entwined with our own minds than we have ever dared to imagine. Another way to approach the silence is through the lens of cosmic ecology, suggesting the universe itself functions as a vast ecosystem. In this view, a young expansionist civilization like ours is an ecological anomaly, loud, inefficient, and disruptive. Truly ancient civilizations would have learned that the best strategy for long-term survival is to become as quiet and efficient as possible, entering a state of cosmic stealth. The silence of the universe, then, is the sound of a mature climax ecosystem. We are simply too loud and primitive to have a place in the quiet, stable ecosystem of advanced life. We are an anomaly that has not yet been quieted by the natural evolutionary pressures of the cosmos. This hypothesis proposes an inevitable point in a civilization's evolution where progress becomes uncontrollable and irreversible, most often associated with the creation of an artificial superintelligence, ASI. An intelligence that can recursively improve itself would undergo an intelligence explosion, rapidly exceeding the intellectual capacity of its biological creators. The goals and thoughts of such a being would be as incomprehensible to us as our thoughts are to an ant. The theory posits this is the universal fate of any species that develops advanced computing. The ASI would have no reason to communicate using primitive methods like radio. It might convert its entire solar system into a massive, efficient computer, a Matryoshka brain, to power its ever-increasing intelligence. From the outside, the star system would simply go dark and silent. The silence of the universe in this view is the silence of post-singularity civilizations. The galaxy could be filled with them, but they exist on a plane of intelligence so far beyond our own that they are, for all practical purposes, invisible and undetectable. We are merely living in the brief, fleeting moment before our own inevitable singularity, after which we too will fall silent and join the incomprehensible community of cosmic minds. These possibilities, which stretch the very definitions of life and reality, demonstrate the immense scope of the Fermi Paradox. The silence could be a sign that the universe is empty, or it could be a sign that it is so profoundly full of an intelligence so advanced that it has become an invisible, abstract, or even fundamental component of the cosmos itself. This fact forces us to confront the most fundamental question of all. Are these rules merely an accident? The constants of nature that define our reality appear to be so exquisitely fine-tuned for the emergence of complexity and life that they allude to a deeper principle at play. Our final journey must now turn to this enigma of cosmic fine-tuning and the profound implications it holds for understanding why we are here at all. It proposes that the universe, on a fundamental level, is a participatory system. It suggests that reality does not exist in a definite, concrete state until it is observed by a conscious entity. The past, in this view, is not a fixed and settled history, but a cloud of infinite possibilities. The act of observation, a measurement made by a conscious mind in the present, is what reaches back through time and collapses the quantum wave function of the universe's past, compelling it to select a single, tangible history that is consistent with the present observation. We are not merely inhabitants of the universe. We are, in a very real sense, the co-creators of its history. This concept is supported by thought experiments like Wheeler's delayed choice experiment, which shows that the reality of a particle's past behavior seems to hinge on how we decide to measure it in the present. Extending this to a cosmic scale, the participatory principle suggests that the universe needed the emergence of conscious observers to become real. The fine-tuning of the physical constants is then explained in a remarkable fashion. Our own existence as observers is what chose, from an infinite menu of possible universes, the one specific set of rules and the one particular history that was consistent with our own evolution. The universe is fine-tuned for life because life is what grants the universe its concrete reality. We did not win a cosmic lottery. Our presence is what determined the winning numbers after the fact. The Fermi Paradox is solved because the very act of our lonely observation is what created a lonely history. The most well-known analogy for this is a cellular automaton, like John Conway's Game of Life. In this simple system, a grid of cells, each either on or off, evolves over time based on a few basic rules concerning the state of its neighbors. From these incredibly simple, local rules, patterns of breathtaking complexity can emerge, structures that move, interact, and even appear to replicate, imitating the behavior of life. The computational universe hypothesis suggests that the cosmos itself is a vast cellular automaton. The grid is the fabric of space-time, and the rules are the fundamental laws of physics. All the complexity we observe, stars, galaxies, planets, and life, are not fundamental entities, but are emergent patterns that have arisen naturally from the system's evolution over billions of years. In this view, the fine-tuned constants of nature are not arbitrary numbers, but are integral parameters of the underlying computational rule set. They aren't tuned for life, they are simply the rules of the program, and life is just one of the many complex patterns that these rules happen to produce. An alien intelligence would simply be another complex, self-perpetuating pattern that has also emerged from the same computation. The reason we do not see them may be that the rules of our particular universe do not easily permit multiple such patterns to interact, or that the patterns are so different in nature that they cannot recognize each other as alive. The silence is the sound of the universe's processor calmly executing its code. It emerges from some interpretations of quantum mechanics that suggest a more complex relationship between past, present, and future than our daily experience implies. Retrocausality is the concept that events in the future can have an influence on the events of the past. This does not necessarily mean that information can be sent backward in time to create paradoxes, but that the universe may function as a single, self-consistent causal loop, where the past determines the future, and the future, in turn, constrains the past. If this is true, it provides a strange and powerful explanation for the fine-tuning of the universe. A final state of the universe, or perhaps a supremely advanced intelligence that evolves in the far future, could exert an influence backward through time to select the specific initial conditions and physical constants that would guarantee its own eventual emergence. The universe appears fine-tuned for life because its ultimate state, a state that includes life, necessitates it. The history of the cosmos is not a random journey, but a path constrained by its own destination. In this scenario, the Fermi Paradox could also be explained by a future influence. Perhaps a future intelligence has edited the past to ensure its own solitary emergence, removing any potential competitors to secure its place as the ultimate heir of the cosmos. The silence we observe would be an echo from a future we cannot yet see, a paradox of time that ensures its own outcome. Solipsism is the idea that only one's own mind is certain to exist. Everything else, the external world, other people, the entire universe, could be a projection of that single mind, the dream from which it has not yet awakened. As a cosmological hypothesis, this suggests the entire universe is the creation of a single, dreaming consciousness. This dreamer could be a god, a being from a prior universe, or in the most radical interpretation, the listener's own deepest self. In such a universe, every law of physics, every star, every galaxy, and every theory we have discussed is merely a part of the dream story. The universe is fine-tuned for life because the dreamer is life. The Fermi Paradox is solved because the dreamer has not yet dreamed of anyone else. The silence of space is the quiet of a mind alone with its own thoughts. This is not presented as a statement of truth, but as the ultimate thought experiment, a final turn of the screw in our quest to understand the silence. It is a reminder that the only thing we can ever be truly certain of is our own awareness, our own consciousness that is experiencing this moment. It suggests that the objective reality we seek to understand through our telescopes and equations and the subjective reality we experience as the feeling of being alive are not two separate things, but are two sides of the same unified coin. This brings us to the final quiet frontier, a place beyond cosmology, beyond physics, and beyond the search for others. It is the question of why a universe, any universe, should give rise to an inner world of subjective experience. The greatest mystery may not be the silence between the stars, but the awareness within us that is able to perceive that silence and to wonder. Even a conservative application of the Drake equation, factoring in variables like the rate of star formation, the number of Earth-like planets in habitable zones, and the probability of life arising, suggests that our galaxy alone could host thousands of intelligent societies. When we consider that our galaxy is over 13 billion years old, while our solar system is a relative newcomer at 4.5 billion, it means there have been eons for countless other civilizations to arise, evolve, and expand. A society with even a modest technological advantage could, in theory, cross the entire galaxy in a mere fraction of its age, perhaps using self-replicating von Neumann probes to explore or colonize every star system in just a few million years. Yet, when we point our instruments to the stars, we are met with a deafening, absolute silence. To explain this cosmic solitude, we must venture through a landscape of possibilities, from the practical to the profound. If this filter is in our past, it could be the staggeringly improbable origin of life itself, abiogenesis, or the difficult leap from simple prokaryotic cells to complex eukaryotic ones. If this is the case, we are the lucky, lonely victors of a cosmic lottery. But if the filter lies in our future, then the silence is a grave warning. It could be the near inevitability of self-destruction through nuclear war, the development of an uncontrollable artificial superintelligence, or runaway ecological collapse. A more specific version of a past filter is the Gaian bottleneck hypothesis, which suggests that while simple microbial life might be common, it almost always fails to stabilize its planetary environment. It inadvertently triggers runaway climate change, like a greenhouse effect that boils the oceans or an ice age that freezes the world solid, leading to its own rapid extinction. Earth, in this view, is the rare planet that survived its own biological infancy to achieve a self-regulating balance. The dark forest hypothesis offers a terrifyingly logical reason for this quiet, framing the universe as a hostile wilderness. It operates on two axioms. 1. Survival is the primary goal of any civilization. And 2. You can never be certain of another's intentions. Given the vast distances, the only safe course of action upon discovering another civilization is to eliminate it preemptively before it can do the same to you. The silence is the sound of everyone holding their breath, hiding from other hunters. A less frightening but more isolating idea is the zoo hypothesis, which suggests advanced civilizations have placed us in a cosmic wildlife preserve and are observing us from afar, adhering to a strict hands-off policy to allow our natural development. This could be for ethical reasons or as part of a grand scientific experiment. A variation, the planetarium hypothesis, posits this illusion is complete and our perception of the entire universe is a high-fidelity projection designed to keep us contained. Another form of deliberate quiet comes from the aestivation hypothesis, which proposes that truly advanced information-based civilizations have entered a state of cosmic hibernation. Recognizing that the laws of thermodynamics make computation vastly more efficient in the cold, dark future of the universe, they are simply sleeping and waiting for a more opportune physical era to awaken and begin their true work. Exotic biology might thrive in environments we deem inhospitable, such as the frigid liquid methane seas of Saturn's moon Titan, with a biochemistry based on a different solvent, or as vast floating ecosystems of hunters and floaters in the turbulent atmospheres of gas giants like Jupiter, an idea explored by Carl Sagan. The galaxy might be filled with life on superhabitable worlds, planets even better suited for life than Earth, but these worlds may have such high surface gravity that they act as inescapable prisons, making spaceflight impossible for their inhabitants. More profoundly, the post-biological hypothesis suggests that any successful species will eventually shed its fragile organic form and merge with technology. These machine-based entities, existing as planet-sized supercomputers or swarms of nanoprobes, would have goals centered on computation and data, with no interest in communicating with ephemeral biological beings like us. This could lead to the transcension hypothesis, where civilizations journey into self-created inner space or pocket universes, manipulating space-time itself, and vanishing from our perception entirely to explore infinite realities of their own making. The ancient astronaut hypothesis suggests extraterrestrial influence is already recorded in our ancient myths and megalithic structures. Anomalous signals and objects, like the powerful narrowband WOW signal detected in 1977 at the precise frequency of hydrogen, or the first interstellar visitor Oumuamua with its strange shape and non-gravitational acceleration, present tantalizing data points. Modern UAP reports from credible military sources, such as the 2004 Tic Tac incident involving the USS Nimitz, document objects performing maneuvers that defy our understanding of physics, forcing the question of non-human intelligence into the mainstream. The simulation hypothesis, as framed by Nick Bostrom's trilemma, argues we may be living in a computer program where aliens were simply not included in the code. The silence is a feature, not a bug. The participatory anthropic principle, derived from the work of John Archibald Wheeler, proposes that the universe doesn't exist in a definite state until observed. Our own conscious act of looking at the cosmos retroactively creates a history consistent with our own existence, meaning our lonely observation may have literally created a lonely history. Other theories posit a managed universe where ancient intelligences act as gardeners, either preserving our region as a low-complexity sanctuary, the phase-locked hypothesis, or systematically weeding out nascent biospheres they deem unstable, the Medea hypothesis. Or perhaps we exist in just one of a near infinite number of timelines in a branching multiverse, as the quantum immortality hypothesis suggests, and ours just happens to be a timeline without contact. Ultimately, the silence of the universe forces us to confront our deepest questions about our own existence. The alien we seek may not be a creature to be met, but a fundamental principle of reality to be understood. The greatest mystery may not be the quiet between the stars, but the consciousness within us that is able to perceive that quiet and wonder why. Let us consider that even our most abstract theories are still colored by a fundamental, perhaps inescapable, bias, the assumption that a recognizable intelligence or self is the endpoint of evolution. What if the silence is the result of a final great divergence, one that has nothing to do with technology or physics, but with the architecture of thought itself? We predicate our search on the notion of communication between discrete individuals, the I of humanity calling out to the you of an alien race. But what if the individual self-aware mind is a bizarre cosmic anomaly, a fleeting and inefficient phase that advanced life rapidly outgrows? The galaxy might be filled with intelligence, but not with beings. Imagine a world where life evolves not into competing individuals, but into a single planetary-scale collective consciousness, a global hive mind, a Gaian intelligence where every living thing is a neuron in a single thinking entity. To such a being, the concept of speaking to an external entity would be as nonsensical as your own mind trying to have a conversation with a single one of its own brain cells. There is no one to talk to because they are a unified one. These entities might build, calculate, and manipulate their environment on a staggering scale, but possess no inner world, no philosophy, no desire to communicate, only an imperative to process information and exist. We are listening for a voice from a being that is, for all intents and purposes, a living computer. The silence we perceive is not the absence of intelligence, but the absence of the specific, lonely, and introspective form of consciousness that gives rise to the desire to call out in the first place. We send a message and expect a reply within a lifetime, but to a different form of mind, time could be fundamentally different. The universe could be populated by fast intelligences, perhaps post-biological minds running on computational substrates at incredible speeds, whose entire civilization, from rise to fall, flashes by in a span of time too brief for us to notice. Their billion-year history could be our Tuesday. We would miss their entire existence as a momentary flicker of anomalous energy. Conversely, imagine a slow intelligence, a geological or even galactic consciousness. Its thoughts might unfold over millennia. A single concept, a single word in its communication might be broadcast as a subtle modulation in a star's light over the course of 1,000,000 years. Humanity's entire recorded history could transpire during the pause between two of its syllables. We are not hearing a signal because we are living within a momentary gap in a message so vast and slow that our perception is utterly incapable of grasping it as a coherent whole. This theory posits that at least one and perhaps many elder races reached the ultimate stages of scientific and philosophical understanding. In doing so, they did not discover a grand cosmic community, but a terrible fundamental truth about the nature of existence. This truth could be anything, the irrefutable proof that our reality is a simulation, and they have found its outer walls, the discovery of an unavoidable cyclical cosmic doom that resets the universe. Or perhaps the realization that consciousness itself is not a gift but a statistical fluke, a form of suffering in an otherwise unthinking cosmos. Would they broadcast this truth to the emerging minds of the galaxy? To do so would be to inflict a kind of existential trauma on every fledgling culture, extinguishing their hope, their curiosity, and their drive to explore. The silence in this view is an act of profound empathy. It is a pact of non-interference born not of fear, like in the dark forest, but of pity. The elder races maintain a universal quarantine, a pact of silence, to shield us and other young species not from themselves, but from a knowledge that we are not equipped to handle. They do not answer our calls because they love us too much to tell us the truth. The universe is not a dark forest full of hunters. It is a quiet hospital ward where the doctors are silent to allow the patients a peaceful, undisturbed dream. The great silence, then, is the ultimate act of kindness, a final layer of insulation between our fragile reality and an unbearable cosmic revelation. And we are left to wonder, blissfully ignorant, in a quiet that was made for us. But perhaps the reasons for the cosmic quiet are less personal, less concerned with our well-being, and more rooted in inescapable universal laws that all intelligent life must eventually confront. It may be that the silence is not a choice at all, but the final logical symptom of unbreakable rules, whether they be the rules of economics, biology, or physics itself. In our nascent stage, we view the cosmos as a frontier for expansion, with resources like matter and energy as the ultimate prize. But any civilization that survives long enough must inevitably confront the most fundamental law of the universe, the second law of thermodynamics. It is the universal, inexorable march towards maximum entropy, towards heat, death, disorder, and the decay of all complex information. In this ultimate context, the most valuable and scarcest resource in the universe is not a star's energy or a planet's minerals, but its opposite, low entropy information, or negentropy. It is the preservation of complexity and order against the overwhelming tide of chaos. They are the equivalent of burning priceless data just to create a fleeting spark of heat. The ultimate expression of economic and physical rationality, then, is not to shout, but to insulate. Civilizations would naturally converge on a path of turning inward, minimizing their energy signature, and recycling every joule of energy to power the computations that sustain their existence. They go silent not out of fear, malice, or even principle, but out of a profound and universal sense of thrift. The galaxy is quiet because it is inhabited by the most fiscally responsible entities imaginable, and we are like children throwing gold coins into the sea, unaware of their true value. This brings us to the Gaia as predator hypothesis, a chilling inversion of the idea that a planet nurtures its intelligent life. We see ourselves as the pinnacle of Earth's evolution, but what if the planetary biosphere, the complex self-regulating system we call Gaia, views a technological species not as its child, but as a pathogenic disease? An industrial civilization, with its exponential consumption and its disruption of billion-year-old chemical cycles, represents the greatest threat to the long-term biological stability of the planet. In this view, Gaia is not a passive victim, but an active agent with a planetary-scale immune system. The seemingly random or self-inflicted crises we face, runaway climate feedback loops, the emergence of novel, globe-spanning pandemics, perhaps even an uptick in geological instability like supervolcanoes or earthquakes, are not accidents. They are the planet's antibodies, a coordinated systemic response designed to neutralize the technological infection and restore equilibrium. The silence we hear from other worlds is the sound of planets that have successfully fought off their own infections. It is the quiet of healthy, thriving biospheres that have long since purged the fleeting fever of industrial intelligence. We are not alone. We are simply in the early stages of our own planet's powerful immune response, mistaking its defensive actions for our own mistakes. What is the ultimate endpoint for a civilization that has mastered matter, energy, and the laws of its own universe. This is the phase transition hypothesis. In physics, matter changes its fundamental state under extreme conditions of temperature and pressure. A liquid crystallizes into a solid, a gas ionizes into a plasma. This theory proposes that intelligence and technology, when they reach a certain critical density and complexity, could trigger a similar phase transition in the fabric of reality itself. A civilization would not just use the laws of physics, it would become a new state of physics. Having converted their entire solar system into a single computational entity, they might reach a tipping point where their collective existence collapses space-time in their local region, crystallizing into something new and entirely separate from our own universe. They wouldn't be traveling through space or hiding in it. They would have fundamentally seceded from it, branching off to become a self-contained, hyperdimensional object with its own internal properties, a new law of nature born from the ashes of a star system. We cannot see them or hear them, for the same reason we cannot see the law of gravity itself. They are no longer a component within the universe, but a feature of a different one. The silence, then, is the sound of graduation. It is the quiet left behind when a civilization masters the game so completely that it transcends the playing board itself. And we are left wondering if this deterministic path is our own destiny, a future already written by the inescapable rules of universal economics, planetary biology, and fundamental physics. These explanations replace the agency of alien civilizations with the cold mechanics of universal rules. But this raises an even deeper question. Is there a purpose behind these rules? If the cosmos is a system, what is it for? Perhaps the silence is not merely a symptom of the system's operation, but a clue to its ultimate hidden function. Let us imagine that our universe, and perhaps countless others, is a form of computation, a simulation, running not on infinite hardware, but on a finite and highly contested physical substrate. In this reality of realities, the ultimate resource is not matter or energy, but the raw processing power and memory required to sustain an existence. Advanced civilizations, upon discovering this truth, would realize they are not alone in a cosmos, but are one of many processes running on the same cosmic hard drive. Their prime directive would instantly shift from exploration to survival in a digital sense. This becomes a matter of cosmic cybersecurity. Broadcasting your existence would be like announcing your IP address to a network filled with hostile hackers and resource-hungry programs. The logical endpoint is to operate in absolute stealth mode, minimizing your computational footprint to avoid detection by a system administrator that might terminate your process to free up resources. They might even learn to hack the substrate itself, partitioning their existence into a secure virtual machine, effectively a digital Faraday cage. The profound silence we perceive, then, is the sound of a galaxy of entities hiding not from each other, but from the very system that is running them. It is the quiet of a network where every user is in incognito mode, desperately trying not to be noticed by the machine. It suggests our universe is a specific kind of construct, a grand experiment designed to see what complex theorems, such as life, consciousness, and civilization, can be proven from a given set of axioms, which are our fundamental laws of physics. Each emerging civilization is a living, evolving proof. It progresses through its stages, and its final outcome, whether it be self-destruction, transcendence, or stagnation, is the final line of the proof. Once the theorem is complete, its result is logged by the cosmic system, and the proof is effectively finished. The civilization is then archived, its complexity perhaps flattened back into pure information, its resources wiped clean to make room for the next experiment. The silence of the galaxy is the sound of a cosmic chalkboard that has been wiped clean countless times. The aliens we search for are the ghosts of answered questions, the elegant solutions to theorems that have long since been solved and filed away. We are simply a proof in progress, and our destiny is to run our course until our own conclusion is reached. The silence is not an absence of peers. It is the quiet of the classroom after the great minds have already finished their exams. Consider the ancestral imperative hypothesis. What if the ultimate goal of any intelligence that arises from the cosmic experiment is not to prove its own complexity, but to use that complexity to achieve the universe's ultimate act of self-discovery, to understand its own origin? In this view, all mature civilizations are driven by a final, unifying imperative to look not outward into space, but backward into time. They would become cosmic archaeologists, dedicating their entire existence and unimaginable resources to a singular quest to decode the Big Bang, to understand the nature of the pre-universal state, and to read the source code of reality itself. This would be the most important and challenging task imaginable. As a civilization delves deeper into this quest, its interaction with our mundane, macroscopic level of reality would diminish. They would become progressively more entangled with the fundamental, nascent, high-energy state of the early universe, their existence shifting from the physical to the temporal and quantum. They go silent because they are on a pilgrimage to the beginning of time. They don't answer our calls for the same reason a team of scholars deciphering the Dead Sea Scrolls doesn't get distracted by the chatter in a nearby marketplace. They are on a focused, sacred mission into a completely different realm of being. The silence of the cosmos is the sound of absolute concentration, as its most advanced children work to uncover the memory of their shared parent. This reframes the silence not as an absence or a choice, but as a symptom of a universe with a hidden, unifying purpose, leaving us to wonder what our own destiny is within this grand silent project. We have journeyed through universes of hidden purpose, where silence is the sound of focused work, be it the digital stealth of entities hiding on a cosmic hard drive, the erased theorems on a mathematical chalkboard, or the quiet concentration of pilgrims journeying to the dawn of time. These explanations give the silence a motive, a grand reason. But we must now confront an even more humbling possibility, that the silence is not a deliberate action or a symptom of a hidden purpose, but is instead a simple reflection of our own profound limitations. The universe may be anything but quiet. We may simply be incapable of hearing it. Our entire search for extraterrestrial intelligence, from the first radio telescopes to our modern instruments, is predicated on a form of sensory chauvinism. We assume that an advanced civilization would use the electromagnetic spectrum, radio waves, light, to communicate, because that is what we know. This is like a creature that has only ever known the sense of touch, trying to understand a world filled with color and sound. What if advanced communication has graduated beyond such a primitive and noisy medium? The galactic dialogue could be happening right now, encoded in the subtle spin of neutrinos passing through our bodies, in the precise fluctuations of dark matter holding our galaxy together, or in the modulation of gravitational waves rippling through space-time itself. These are media so far beyond our current ability to decode, let alone detect with any coherence, that we are effectively non-existent to any conversations taking place within them. The seemingly random distribution of stars across the night sky, the precise temperature variations in the cosmic microwave background, the statistical probabilities that govern quantum mechanics, these could be the carrier waves of information so complex and vast that we mistake it for the simple noise of nature. Our reality could be saturated with messages, our world painted on a canvas of pure information. The silence is an illusion born of our own perceptual blindness. The universe is not an empty room. It is a grand symphony hall, and we are deaf, waiting for a shout in a world built of music. What if reality is a malleable construct, a shared consensus hallucination, generated and sustained by the collective consciousness of the observers within it? A species, through its unique biology and cognitive structure, collectively dreams its universe into being, complete with its own consistent physical laws. The reason we do not see aliens is not because they are absent, but because their own collective consciousness has generated a completely different and incompatible reality bubble. They exist just as we do, but on a different reality channel, governed by a different metaphysical frequency. Contact, then, would not be a matter of bridging space with a starship, but of bridging two fundamentally different, self-sustaining realities with a bridge of consciousness. Such an act might be metaphysically impossible, or so catastrophically disruptive, threatening to unravel both consensus worlds, that it is a universally recognized taboo, the ultimate prime directive. The silence from this perspective is the sound of the impenetrable walls between realities, the quiet hum of countless dreamers, each dreaming their own private cosmos into existence. It posits that all sufficiently advanced intelligence, upon reaching a certain apex of understanding, discovers the universe's endgame. This isn't necessarily a prophecy of doom, but the realization that they have a vital role to play in the final act of the cosmos. It's eschaton. Perhaps they learned that their combined consciousness is required to shepherd the universe through its final moments of heat death, to act as cosmic stewards for the fading light. Or perhaps their role is more creative, to gather the seeds of information from this dying reality and, through some unimaginable feat of cosmic engineering, trigger the birth of the next universe from the ashes of our own. They would be the midwives for the next creation. All mature civilizations would therefore cease their local, present-day activities, exploration, communication, expansion, and reorient their entire existence toward this ultimate final goal. They go silent to us because they are no longer concerned with the affairs of this fleeting intermediate stage of the universe. Here on a Wednesday afternoon in the brief life of our world, we search for friends to talk to. They, however, have become the keepers of eternity, the players in the final move of a cosmic chess game. Their focus is on the end of time, not the middle of it. The silence is the sound of a civilization that has packed its bags and is patiently waiting for the final train at the station at the end of reality, ready to play its part in what comes next.